All right. So again, we're adding. So remember the directions are going to say added. We're adding and subtracting rational expressions. All right. And um, so the directions will say perform. It will probably say perform the indicated operations. Indicated operations. All right. So I'm going to put this one as number one. Okay. So number one, we have this. We have 7 divided by x squared minus 5x plus 6 plus 6 divided by x squared minus 2x. Okay, now remember, when adding and subtracting fractions, rational expressions, the denominators have to be the same. Notice that these denominators are different. So what you got to do now is you got to find the least common denominator. And to find the least common denominator, let me get that page. To find the least common denominator, that's where you're going to first of all factor. Remember, you're going to factor each denominator completely. So you're going to factor this denominator, you're going to factor this denominator. This denominator is a quadratic trinomial, so I can factor that one as x minus 3, x minus 2. This is quadratic, but it's a binomial. So notice though that the GCF here is x. So you're going to factor out an x. So I get x times x minus 2. All right, and now your least common denominator, your least common denominator is the product of all the different factors that you see. And if you have more than one factor that's the same in the denominator, you can use the one that's the greatest. So I have an x minus 3, I have to use it. I have an x minus 2, I have to use it in my LCD. I have an x, I have to use it, but always put the monomial part, the monomial factor at the beginning. So put the x in the front. So you have a monomial times a binomial times a binomial. I have an x minus 2, I already have it. So this LCD are these three factors that you see here multiplied together. So now you're going to write, so the next step, once you write, well, I'm sorry, once you find the least common denominator, now remember this is where you're going to write your equivalent expressions. Okay, so we're going to write 2. You have two fractions here. So you're going to write two fractions with this denominator. So x times x minus 3 times x minus 2 plus, and then same thing again, x times x minus 3, x plus 2. I'm sorry, x minus 2. Okay, so remember what you need to do. Kind of circle this right here to remind you that this is what I have. So I want to write an equivalent rational expression for this that has these factors instead of these two. So I have the x minus 3, x minus 2 already, so I'm missing the x. So you're going to say times x times x. So now this rational expression is equivalent to a rational expression with this denominator if it has this numerator, 7 times x. So put 7 times x. And again, you notice if you cover up the two factors they have in common, what you see 7 divided by this is what's circled. Then you go to the next one. I have the x and the x minus 2. I have the x and the x minus 2. I'm missing the x minus 3. So you're going to say times x minus 3. So you see this is now this. But what I do to the denominator, I have to do to the numerator. So this rational expression is equivalent to a rational expression with this denominator and this numerator, 6 times x minus 3. And so now you have two rational expressions with the same denominator. So you can write this as one rational expression, x times x minus 3 times x minus 2. And you're going to add the numerators now. You're going to say 7x plus this. So 7x plus 6 times x minus 3. And now distribute. You get 7x plus, and then 6 times x is 6x. 6 times a negative 3 is a negative 18. Divided by x times x minus 3 times x minus 2. Combining like terms, 7x plus 6x is Was that 13x? 13x minus 18 divided by x times x minus 3 times x minus 2. Now remember, the next step is once you get to that point, you have to make sure you reduce the rational expression if you can. So remember, to reduce a rational expression, you got to factor both the numerator and the denominator. Your denominator is always going to be factored because that's what your LCD was made of. It's made up of a product of factors. So that's why you got to leave them in factored form. The numerator, you got to see if you can factor. The GCF here is 1, so that means there's nothing else you can do. So that's this one. All right, let's look at number 2. So number 2, so it's the same process over and over. So notice in part 1 that we just did, the steps are the same. Part 2, the steps are the same. All right, so let's look at this one. So this is number 2. We have a plus 5 divided by a minus 2 minus, and then we have 5a plus 18, that's an 18, divided by a squared minus 4. All right, so I have two rational expressions that I'm subtracting. The denominators are different. So I got to somehow get those denominators to be the same. So that's where the least common denominator comes into play. And remember, you got to use the least. So to find the least common denominator, you got to factor those denominators. Well, a minus 2, I cannot do anything else to it. The GCF here is 1. It's a linear factor. The GCF is 1. Here, though, that's a difference of 2 squares. So I can factor this as a minus 2 times a plus 2. That's how I can factor that. And so now I can find the LCD. Your LCD includes every unique factor that you see. I see an a minus 2, I have to use it. I see an a minus 2, I already have it. I see an a plus 2, I have to use it. So this least common denominator is a product of these two factors. So now you're going to write equivalent fractions. So that's at step 2 now. So you did step 1, now you're going to do step 2. That's where you're going to write equivalent fractions, equivalent expressions using that LCD. So right underneath, you're gonna rewrite this right here with that denominator, and same thing with this one. So a minus 2, a plus 2 minus, and then a minus 2, a plus 2. All right, and then you ask yourself, I want to rewrite this expression into a different expression, an equivalent expression with this denominator. So I have the a minus 2, I'm going to cover it up, so I need the a plus 2. So I'm going to say times a plus 2. What I do to the denominator, I must do to the numerator. But notice, just like we did in another problem, this rational expression is equivalent to a rational expression with this denominator having this numerator. A binomial times a binomial. So put that in parentheses. You're going to say a plus 2 times a plus 5. Okay, this times this goes here. Over here, I want you to notice something. These factors are the same, right? So you already have this right here is the same as your LCD. So that means this. So that means you can say, well, can I multiply by something like I did here? Yeah, you can. This times 1. This times 1 is this. So what I do to the denominator, I do to the numerator, and notice that's the same thing, right? 5a plus 18 times 1 is 5a plus 18. So these denominators are the same, so the numerators have to stay the same. Now, these two rational expressions have the same denominator, so now I can write this as one rational expression with that common denominator. A minus 2, a plus 2. And so your numerator is going to be this minus this. Now, be careful with the subtraction here. So this, a plus 2, a plus 5, minus, now be careful, you are subtracting all of this. So you must put all of this in parentheses. If you don't put this numerator in parentheses, you're going to mess up and you're going to have this as a positive 18 in the end, when if you distribute, you notice it should be a negative 18. So that's why you got to be careful with this one. All right, so now we're going to FOIL this out here. See a binomial times a binomial, so these use the fall method. So you can rewrite this with the denominator. And see, I just want to remind you, this looks just like we did here. See this right here? Remember there was another problem we did in part 1? Remember this one? We foiled. Okay. All right. So a times a is a squared. The outer, a times 5 is 5a. The inner, 2 times a is 2a. The last, 2 times 5 is 10. Okay. Now let's distribute the negative. Negative, you can think of this as a 1, or you can think of this as taking the opposite of 5a. Distributing a negative 1 or taking the opposite of 5a, that becomes a negative 5a. The opposite of a positive 18 is a negative 18. Now combining like terms, notice what happens. I have a squared. 5a plus 2a is 7a. 7a minus 5a is 2a. So I get a positive 2a. 10 and a negative 18 is a negative 8. So this right here is this quadratic trinomial divided by a minus 2, a plus 2. Now remember, once you get to that point, you have to simplify this rational expression in lowest terms. And to do that, remember that was a couple of weeks ago, you got to factor the numerator and the denominator. Well, remember the denominator is always going to already be factored because that's your LCD. Your LCD is a product of factors. You just have to factor the numerator. So let's go ahead and factor the numerator. Let me go ahead and rewrite the denominator. When I factor the numerator, this becomes a plus 4, a minus 2. That's what this becomes. And now notice the a minus 2's divide out. So you cross them out, factors of 1, and your answer is a plus 4 divided by a plus 2. Same process. Every problem we've done was the same process. All right, let's look at number 3. We still have time for a couple more. So let's look at number 3. Number 3, let's suppose we had this for number 3. Let's see. All right, let's do this one. We have 3 divided by x minus 8 plus 6 divided by 8 minus x. Now, don't let this one throw you off because you may see this on My Math Lab. I want you to notice that, see these right here? Those are opposites. X minus 8 and 8 minus x are opposites. So that's what you had to recognize. You have to recognize that these two denominators are opposites of each other. So what I could do is, for this one, it doesn't matter which one, but I'm going to do this one, I could factor out a negative 1. So if I factor out a negative 1, just like I'm doing, I get negative 1 times a negative 8 is a positive 8. A negative 1 times a positive x is a negative x. And I'm going to rewrite this to make it look like this. Negative 8 plus x is the same as x minus 8. So this and this are the same. See that? This and this are the same now. Now I want to show you something. I'm going to go ahead and rewrite this as 3 divided by x minus 8 plus 6 divided by negative 1 times x minus 8. So I just wrote this as 6 divided by this right here. I'm going to cover this up. You have to notice this now. You have to notice that 6 divided by negative 1, 6 divided by negative 1 is the same thing as a negative 6, as rewriting this as a negative 6. So 6 divided by negative 1 means the same thing as negative 6 divided by 1, or negative 6. So which means this. I'm going to rewrite this as 3 divided by x minus 8 minus 6 divided by x minus 8. So all of this becomes this, and notice the denominators are the same. So now you get, since the denominators are the same, you can write as one fraction, and you can have 3 minus 6, which gives you a negative 3 divided by x minus 8. So that one, a lot of students forget about the idea of opposites, but sometimes, now I don't think on the worksheets you have any that are opposites, but on My Math Lab you could have the idea of opposites involved. All right, so let's look at number 4. Number 4, let's try this one for number 4. Let's do um, let's see. Okay, so let's do this one. We have 4x divided by x squared plus 3x plus 2 minus x plus 7. I'm sorry, x minus 7. X minus 7 divided by x plus 1. All right. So notice that these fractions have different denominators. So in order to subtract these two rational expressions, the denominators have to be the same. So you got to find the least common denominator. Before you find the least common denominator, you have to factor these denominators. So to factor this one, this trinomial, I can factor that as x plus 2, x plus 1. This I cannot factor. That's a linear factor. The GCF is 1. So now I'm going to find the LCD. The LCD must include every unique factor that you see. I see an x plus 2, I have to use it. I see an x plus 1, I have to use it. I see an x plus 1, I already have it. So my LCD are these two factors multiplied together. So now you're going to write two equivalent rational expressions with this LCD as your denominator. X plus 2, x plus 1. X plus 2, x plus 1. All right. Now, in part 1, we talked about this. See, this denominator right here is the same as this. So if your denominators are the same, so this rational expression is equivalent to itself. This denominator is the same as this denominator. So 4x has to go here as well. See, the denominators are the same. So you can say times 1 times 1. 4x times 1 is 4x. Over here, though, see how the x plus 1, I'm missing the x plus 2. So you got to say times x plus 2 times x plus 2. Now, this is where you have to be careful. So now this rational expression is equivalent to a rational expression with this denominator having this numerator, though. X minus 7 times x plus 2. So you may recall in a previous problem, this one right here, the two binomials were in that first fraction. Now the product of these two binomials are in the second one. All right, so it's just in a different part of the problem. You got to be careful here though, because that's a subtraction. Many students mess up with the subtraction symbol right here. So be very careful. So now I have two rational expressions with the same denominator, and that's supposed to be a 1 right here. So I'm going to write this as one rational expression. X plus 2, x plus 1. And then my numerator is going to be this minus this. This minus this. So in other words, 4x minus x minus 7, x plus 2. All right, now we're going to FOIL this out right here. Be careful because you're subtracting whatever this is. So here's what I'm telling you to do. Just like right here, where when we subtracted this numerator, remember I told you to put that in parentheses, right? Okay. So when you FOIL this out, I'm gonna put it right here. The denominator is x plus 2, x plus 1. So you get 4x. When you FOIL this out, you're gonna say minus, and you're gonna put all of this in parentheses. So x times x is x squared. The outer, x times 2, is 2x. The inner, negative 7 times x is a negative 7x. And the last, a negative 7 times 2 is a negative 14. And now we're going to combine like terms here. So let's do that next. So combining like terms, I get, let's see, I'm running out of room here. I get 4x minus, all right, combining like terms in that parentheses, I get x squared. 2x minus 7x is a negative 4x. And then minus 14. I'm sorry, 5x, excuse me, negative 5x. 2x minus 7x, negative 5x. Now distribute the negative. So this becomes, I'm going to do that here. So now this becomes 4x. The opposite of x squared is a negative x squared. The opposite of a negative 5x is a positive 5x. The opposite of a negative 14 is a positive 14. Combining like terms and putting in descending order, I'm running out of room. Put in descending order, I get a negative x squared. 4x plus 5x is 9x. and then plus 14 divided by x plus 2, x plus 1. Now, when you get to that point, this is a lot of work here. When you get to that point, the next step is to reduce your rational expression if you can. Notice that even if you factor out a negative 1 from here, you cannot factor this. This is not factorable. So if you factor out, now be careful, you may say, well, x squared plus 9x plus 7 is x plus 7 times x plus 2. That's true, but that's not x squared, that's a negative x squared. So this is not factorable. So that's your answer. Be careful because this is a negative x squared, not x squared, negative x squared. All right. Now that one was a hard one. Number 4 was a hard one. On a test, I'll be honest with you, on a test, I'm not going to give you one that difficult because you could easily, anywhere in here, you could have easily messed up. You could have messed up when you multiplied here. So I'm not going to give you one that's that difficult, but on a worksheet you can because you have time to work it out. Okay? Just make sure you understand why this is not factorable because if the negative wasn't there, then this would be x plus 7 times x plus 2. But it is not x squared, it's a negative x squared, so that's no longer factorable. Okay? All right. Okay, so we did a lot here, but I think that gives you enough for what we're doing this week to get you through the part for this week. So this is, or this was, adding and subtracting rational expressions. We did two parts. We did a part 1 and we did a part